A warm good evening to everyone. I welcome you all to the Net Zero Energy Building Knowledge Series. This is a weekly webinar series where I bring to you experts from India and abroad, talking to you about energy efficiency, design, technology, renewables, even policy and skills, everything that's to do with net zero energy buildings. This initiative is brought to you by the METRI program, which is Market Integration and Transformation for Energy Efficiency, funded by the USAID. You can get more information on metri.edsglobal.com. Today, we are going to discuss about two projects. One is a retail store for PUMA located in Banglore, and the other is a 90,000 square feet office building for Karnataka Power Corporation Ltd. These both projects are very different. One is a very small retail space and the other one an office building. Yet both these projects have attempted to bring in passive measures, energy efficient technology, low energy cooling solutions, and so on. So it's an interesting take at how the same approach could be applied with an interesting outcome for different scale of projects. About myself, I'm Deepa. I'm an architect and a green building consultant working for Environmental Design Solutions. I will be the session moderator today. And with me, I have our speaker, Meghana Dutta, who is the designer on this project, and she will discuss with us how her thoughts and process went into implementing these two buildings. Meghana is a founding partner of Studio Decode. She leads the firm's initiatives in research and implementation for their sustainable efforts. She has been a visiting faculty at colleges of architecture and has lectured in conventions and institutions. She has a master's in environmental policy and international development from Harvard University, along with a master's and bachelor's in architecture. Before we jump into the project, let me briefly give you a little orientation, a little introduction about what we are going to talk about. We will first talk about the retail store for PUMA. This project is located in Bangalore. The construction was completed in 2013, and this was part of a winning competition entry. So that means this high performance building is operational since a few years. So we'll get an interesting and different perspective from this project. And second, we have the headquarters, which is an office building for Karnataka Power Corporation Ltd. It's a 90,000 square feet building located at Raichur, and currently the construction is ongoing. Why are we talking about these two projects? Because these two projects are a good example of passive solar strategies, passive building design, and an integrated workflow. Both projects have low energy cooling systems like earth air tunnel in PUMA, vapor absorption systems in the office building, and they both have integrated renewable energy in their buildings. In fact, the retail store even has a building integrated photovoltaics. So all of these elements qualify this project for a high performance building. And this is the approach which is necessary to ultimately achieve the goal of net zero. And hence, these two projects are a perfect fit in our webinar, and we're going to learn more about these aspects. So now let's get started with the first project, which is PUMA. So I'd like to first ask Meghana to brief us about the competition. What was the brief given by the client? What was the part? Firstly, brief us about the competition and what aspect of your design made it stand out and win?
Hi, Deepa. Thank you for introducing the two projects that we're going to present today. Good afternoon to everybody. With regards to PUMA, it was an invited competition, and it was a very simple brief given by the Germans because this was initiated by the German headquarters. I mean, PUMA's headquarters in Germany. And it was a very simple instruction saying they want to do a sustainable store that is beyond any of the certifications, whether LEED or GRIHA. They said they wanted something beyond that. That is like a flagship store for them across the globe. And they wanted it to be the first sustainable standalone store. And they chose India for various reasons. They chose India, and of course, Bangalore is Puma's headquarters in India. So Bangalore was, taken as the place for where they would construct this standalone retail store. And the reason why they probably selected us was we didn't focus only on the efficiency of the systems. Our focus was as a combination or a holistic attempt of design with sustainability. The experience of the store was very critical in addition to the efficiency that we had to achieve for a zero energy building. And we also went beyond saying if we're going all out and it's going to be a sustainable store, let's make it net zero for at least the retail portion of the area. So that was our ideation, and that's what we presented to them, which probably won us the competition. Yeah, Deepa. Deepa, shall I
Right,
continue with
right.
the?
Just a minute, Meghna. Actually,
Yeah.
I think some of the people were not able to see the PPT. I apologize for that. I think now you can see it, and we've not missed much. We've just got started. So we will continue from here. So yes, Meghna, thanks for that orientation about the competition brief, and that gives a little, background as to how this project has panned out, as we can see it right now. So now I'll just request you to walk us through the project and the design process, and also let us know how the brief evolved during this process. You have the keyboard and mouse controls.
Thanks, Deepa. So to continue from beyond the competition brief of how we progressed with the project, so the brief given to us was, like I said, we had to exceed the standard expectations of a green building. So our design approach and strategies for this, it was a very small site, so it was quite challenging for us to have a zero energy building in a very small site. It's like 60 by 90. So it's a very small square feet. And we had a lot of players in it. We had the Germans, we had the Indians, the Puma people who are going to manage the store, and we had the landlord who owned the land because the Puma leased out the property. So we had to ensure that all three expectations were met. And with the program, I mean, with the challenges, evolved the innovation in some sense because I'll just go through the plans and then I'll come into how we approached each of these challenges. So, sorry. So, first to understand what were the sustainable elements that we wanted to incorporate is what we started listing out. What do we want in this building? So to make it a zero energy building and to for such a small area, first we had to think alternative methods of cooling and to avoid artificial cooling as Bangalore has pretty much good temperature for at least 6 months in a year. So we went back to the discussion board and said, okay, let's use the old concept of earth air tunnel for cooling because all we need is, the constant air cycle or air movement rather than cooling the air because outside is pretty much cool in Bangalore for at least 6 months. So we said we'll incorporate that into our design strategy. And then taking it forward, we said let's use the underfloor air diffuser because we don't need to cool above 7 feet and then we can reduce the cooling load further. To take it forward again, we said, okay, the other next step is the standard step, which is a high efficiency VRV systems. Then coming to the materials, it's the porotherm and concrete panel and glazing and all those other materials, because we were limited in terms of the roof area. The roof area could give us only 28 kilowatt of solar panels. So we had to work backwards in terms of design to ensure that the retail takes in only 28 kilowatt to run the place for at least 6 months in a year. So that's how we started. That was a challenge, and we worked backwards to see how the cooling load could be reduced. So these challenges were then translated into how we approach the design. So these are again the materials and aspects that you would normally use in any green building, whether it's insulated roof, low VOC, vertical green wall, including the furniture. Every piece of furniture in PUMA we had to redesign so that it is again a holistic approach towards sustainability, and it's not left to the building shell alone, but it's carried through and through. So in terms of the design process, so the first slide that you see, I don't know if you can see my pointer. So the first, this one that you see is where the site is located. So it's in Indranagar. For those of you who are familiar with Bangalore, it's quite a densely constructed area with a lot of retail and restaurants, packed in together. So it was a small site sandwiched between buildings where there's not much setback. So the opportunity of getting light from the setbacks is very minimal. And it's an east-facing site, which is also challenging because you get a lot of heat coming in the first few hours in the morning. And going to the next slide, what we said is, okay, since this is the east and the back is the west, it was easy for us to put in all our circulation, storage, and all to the west. So it automatically shields the back, the portion of the retail from the direct heat gain of the west. Then coming to this one, then we said, what can we do now? Because we want light to come into all parts of the ground floor, and we are limited in terms of daylight entering from the two sides. So we put in the block as we offset the block so that we can get in light from all the three sides, all the four sides actually. So we recess the block within and we lifted it up. So then what happens is we have the opportunity of light coming in from all the sides and the opportunity of hot air being exhausted from all the sides through stack effect, simple stack effect. So with the concept of then we start, okay, with the concept of earth air tunnel, we're able to get the underfloor air diffusers here and the hot air can rise from all the sides. So it was a very simple solution to a problem that it's quite common in the cities. And the east facade, we could not compromise at all because that is where the main visibility is from the road. So there was no question of us compromising the east facade. So that was a big glazing over there. So what we could do was add a huge canopy with integrated photovoltaic panels. So that acted as a shade for the eastern glazing, as well as allowed us to generate the solar power. So this is how our main design approach was. I'll go on to the next slide. So you can see this central portion being suspended from the roof so as to allow us to get a clear ground space with light to enter into the ground floor from all the sides. And this, because it's a very tight site, we had pretty much just about 5 or 6 feet in the setback. So we got in the fresh air from the side, went into the earth air tunnel, and then from the earth air tunnel, it went into the air handling unit where there's a BMS installed to see whether it needed to be cooled further or not. Otherwise, it would just get filtered and then go back to the basement ceiling from where the diffusers, the cool air enters all the floor diffusers. So the hot air goes in through the extractors on the roof on all the sides. It's a very simple stack effect program. As well as what this allows us to do, this suspended volume, it allows us to connect the multiple retail spaces to the ground floor, which is also equally important in terms of a successful retail. The secondary thing why this was done was also because the landlord would want to put back regular slabs once PUMA leaves this space after 10 years. So if we had to suspend this volume, it should be such that it can be removable at any point of time and reused. So we came up with the concept of having just a metal structure with bamboo cladding. So at any point of time, this whole structure can be removed and reassembled in the same manner or used in whichever way they want. And the landlord can construct his regular slabs for rental of to rent it to future people. So it's a section showing the suspended volume, which is the shaded portion. The back of the house is in the western area, and we had a double stacked car park, and there was earth air tunnel in between this space and this space, and it also continued through the ramp. I have another diagram to show the earth air tunnel in clear. And this was the eastern facade, which had a big canopy in the front as well. So it's an exploded view to show the same thing that I just explained. So this is the basement floor with the earth air tunnel, the ground floor with the diffusers, and this is the simple volume, the envelope, and this is the suspended volume in the center, which acts as mainly a design element, but also serves the sustainable elements that we wanted to integrate into this project to make it a holistic building. So, go further. Yeah. So to give a little bit more of how we integrated the earth air tunnel, these were the 4 inlets that we had, and it went in between the car park areas, and it continued on the ramp. Because the space was limited, it was quite challenging to route the earth air tunnel. In a larger building, we would not have had all these issues, because if this was done incorrectly, it would have been very, very difficult to service it or repair it, because it's very much underground. It's at minus 22 feet 6 inches in such a small space. And to give a little detail, the cost of the project did not allow us to incorporate Rihor, which is ideally the most suitable for earth air tunnel. Because of the transfer of heat and all that, the properties of Rihor piping is much better. But because of the cost implication, we had to go with a simple material such as PVC. But we had to increase the length of the pipes because the efficiency is not as much. And any plumber can do this job, so it is not as complicated as people would generally assume it to be. And even with the simple insertion, we were able to reduce 5,530 kilowatt hour, which is quite a significant amount for a small project. And to show the energy that it would consume, PUMA, it was about 41,290 kilowatt hour. That is a retail portion. And we had planned the roof to take in 28 kilowatt, that is equivalent to about 42, 43 kilowatt hour. But they have not yet installed all the solar. They have installed only 10,000, 11,000 kilowatt hour at 7.2 kilowatts is what they have installed, which is the integrated photovoltaic. The rest of it, we are hoping that in phases they would install it and make it zero energy, which was what the initial intent was. These are some images to show that because we have incorporated a lot of sustainable elements, that we do not have to compromise in any way with regards to the design.
Right. Yeah, I think, Megha, this was a good overview, good insight into how you've designed the building, how you thought about the volume, and how we can actually see the way it is right now, because this is the real photo of the building. There's good daylight in the building. You talked about building integrated photovoltaics. So now this building has been in operation since 2013 or so, right? Uh,
Yes.
and while I was talking to you, also mentioned a lot of effort that actually went into researching and integrating the earth air tunnel in this building. Now, in the operations, now that people are occupying it and managing it, how easy it is to operate the earth air tunnel system. Any feedback from the occupants on how easy or challenging it is to operate it?
So in this particular case, they are finding it a little challenging to maintain the earth air tunnel because it's in a very tight area and it needs regular management because there will be like certain water logging that can happen because of water that deposits, and we have given the slope and the all those kind of things have been taken care of, including a pump, so that if water does fill into that fan chamber that they can remove it. So those things have been forethought and solutions have been provided right at the beginning because we did do a test even before they started. But it does need, like any other, it's not just that earth air tunnel is complicated. It's just that it is seen as an additional chore for people. It's like how you would maintain your glass, or how would you maintain your chiller, or how you would maintain anything that you have in a building. You have to maintain it to a certain extent. So this is just one more thing that is added that people have to take control of and say this is not extra, but it is just an integral part of the building system.
Right. Yeah, well said. I think, like everything else, this also requires its own set of, routine maintenance that it calls for.
Yeah.
So now we'll go over to the second project. And then I know there are some common threads between the first and the second, and we'll try to discuss that together towards the end. But let's just also have a understanding of the second project, which is the office building for Karnataka Power Corporation Ltd. So again, I'd like to first, uh, have you brief us about this, the client vision. What was the goal for the project, and what was a brief to you?
So this project, if I may say, this was initiated in 2009. So it's a 10-year-old project that had been stalled. It's a government project, so it does happen in government sector that it stalls and then it restarts. So currently the construction is in full progress, and we hope to see it finished by the end of this year. It was initiated by an IAS officer, Mr. Jamdar, whose vision was very simple, that this was for Karnataka Power Corporation, and they are the power generators for Karnataka, and they should set an example of how they can design an efficient building that consumes less energy. So that's all his vision was, that we should set an example for the whole country of how sustainable buildings can be built. And it was, again, they had invited about 16 firms to participate in this tender process that they call. And each of us had to meet with them and discuss our ideas and our way we approached and what we wanted to do for this building. And we were happy to be selected, and we got the project. And even after 10 years, we still feel very strongly attached to this project because of the various elements that we have integrated. It was almost like an approach that we took of traditional building methodology with contemporary technology, and how do we integrate these two without, like again I said, without compromising on the experience of the space, or like how poetry is in architecture, how do you experience spaces poetically. We do not want to compromise on any of these things, and this space is in Raichur, where there are power plants. There are 7 of these power plants over there, and it's a very tough conditions to work in. So again, the vision that was given to us was these people are working in these extreme conditions. It's 45 degrees, and you have this coal dust, and they work in asbestos sheets and with just fan. And he really wanted them to have a good building because they're really putting in a lot of effort to work in those conditions. So he wanted them to have the best space.
Right. So now please walk us through the design process for this project, and also, since it's been a long time, like 10 years, like you said, also while you explain to us the building, do highlight, how this brief has evolved. Often we see, even in our practical experience, that there is a brief to start with, and then that evolves, that gets modified, and maybe new goals are set in, or maybe it is completely different than what you started out with. So just also help, walk us through that as well, how the brief evolved, what are the new things you brought in onto the table.
Mhm. So the brief in reality evolved very, very marginally. It was more like how many people are we going to accommodate? I think it was very minor in terms of the larger vision. The larger vision stayed consistent that it would still be a sustainable building. It would still stand apart. It would still be experienced as wonderful spaces that people can occupy. So none of the larger intent changed, but the smaller aspects changed of can we incorporate this many cabins or can we incorporate that, so it was more of furniture requirements that changed and not much of the other portions, which we were happy with because the intent was that was set was a very good start and we didn't really want that to be diluted in any way, even with time. And what happened was that because they liked this building, this they wanted their headquarters in Bangalore, which is their main headquarters, to be designed by us. So we completed that project. So that is supposed to open anytime soon, like interiors, like final interiors are going on right now. And that was double the size. It was like 2.5 lakh square feet, and that's the headquarters. So all the focus of Karnataka Power Corporation went into their main headquarters in Bangalore, and this was neglected to a large extent for various reasons. Now that that is over, we feel positive that they would finish this also in the same pace now, the way the Bangalore project went in. And in terms of to run you through the design requirements, so in terms of their requirements, it was very simple requirements. They wanted a good training hall, a cafeteria, a library, conference, and office space because a lot of training goes into it because it's highly specialized engineers who monitor these power plants. So they need this training session and they need large training halls. Just 1 second, I think I'm trying. Yeah. And again, we sat down and we said, okay, what do we want this building to stand for? Because we already knew that this should set an example, and we also knew that we wanted to integrate the traditional building methodology along with the contemporary technology. So we were clear about that. So similar to the PUMA project, in terms of how do we reduce cooling, we started with a simple thing of earth air tunnel, whereas over here it is much more easier because it's a 5-acre property. They actually gave us 7 acres, but we said we don't want 7 acres. You give us less, you give us 4 or 5 or even 3. So they reduced it to 5 acres. And with 5 acres, we started designing the project. And we kept these as the standards like the double glazing, overdeck, low VOC. So those remained as standard specifications. But what do we do beyond that? How do we design it so that it's beyond just a specification or a list of specifications was our challenge so that it stands out and it feels like it belongs to Raichur. It should not be like a building that can just be, taken over and put into another area. It had to feel like it belonged to that area. It had to feel like people should identify with this building. So that was very important to us to create a sense of identity to this place. So to start with, this was our little site that we got. This was about 5 acres. And these were all the 7 plants that we told you. And there were a lot of trees, as you see. Even though it's Raichur, I think KPCL has done a fantastic job with the plantation of trees across the Raichur thermal power station. It's a massive township that they have, the Raichur thermal power plant, and this is within the thermal power plant campus. And they also wanted a bridge to connect to their unit so that engineers can easily walk from the control room to the office building. So this was the site that was given, and we wanted to locate it along the north and south axis without disturbing any tree. And so as to not kill any trees, we had to take a slight shift that you see in this drawing. And then we raised the southern portion of the building so that the northern terrace is shaded at least to some extent by the southern volume. Then we went in and said, okay, because it had to be a really simple, cost-effective building that is very easy to construct. Those were very clearly informed to us. It's in Raichur. They cannot get the best, team to constantly monitor what is going on. So it had to be very simple and fast and easy to construct and cost-effective. Then we just inserted two codes. These are all again very simple methodologies that are, just responsible in terms of how you approach design and architecture. So this was the shape of the building that we evolved at, with two courts and the little shift. And they were very particular about having these massive roads and car parking, even though there was going to be only one or two buses, but they felt that when the engineers come, they should have that much of space for car parking. But we have given in our landscape thing that every parking area will be shaded. And we took a lot of pains to evolve a design language, even with the way the roads are planned, integrated into the master plan. So it feels like even that is design. It's not just a road that is added at the end of the project. So I'll just go through a few of the elements, again, the simple design elements that we have introduced. So we have those two courtyards like I had shown you in the plan that we have introduced. And the two courtyards have a complete grill work at the top so that it is shaded. Otherwise, nobody can use the courtyard at 45 degrees. And we have also introduced landscape on all the three sides at the terrace level so that they can have greenery growing from the pergolas, so that this can be shaded in addition to having plants at the trees at the courtyard level. So these are massive boxes like 5 feet by 5 feet so that we can actually grow large trees that can shade the courtyard. Otherwise, people would not want to come in and sit. So it's again natural ventilation based on simple introduction of courtyards. In coming to the next one, which is daylight, the width of the building was restricted to 20 meters. So in this particular project, we had a lot of opportunity and flexibility in terms of designing the building because we did not have the problem of lack of space. So we could plan and design, and the requirement was only 90,000 square feet for a 5-acre property. So which is very much different from how we would design in an urban area. So 20 meters, so there was no issue of having daylight to illuminate all the spaces, plus the introduction of the courtyards at regular intervals. So you have ample daylight for every workstation. So even the interiors that we have planned, so all the cubicles are only at 3.5 feet. So there's no blockage of any view at any point of time. And we have a light shelf as well to take in the light further into the space. So here you can see the light shelf so that the light can go in further. And we have these regular fins which are 600 deep. So those shade direct light, so there's no direct heat gain that enters into the main office areas. So we incorporated a simple system of layering when it came to how we approach the design of the space. So the first part is the structural shell. So very simple building. For us to convince the government to go ahead and build this building as it is, we had to convince them of the simplicity of the approach that we have taken, and yet that it would be still sustainable. So we showed it to them that it's a very simple column and beam structure with just two courtyards. We've added water around it as a second layer for evaporative cooling effect. Then we have landscape to protect the heat from the roof. And then the upper roof we've used for solar panel. So 7.5% is what, 7.5 to 10% is what they're deciding on for providing of solar panels. So heat gain is avoided from the roof due to this. And we have fins that we have added. Again, this is an old traditional system, so that there's no direct heat gain. So it cuts down the intensity of light. Then we have added the skin. So the skin is similar to jali in traditional buildings. So where it filters the air, and also in some sense purifies the dust, because right after the skin we have the water, so the dust can settle down before it goes into the main office area. So you have this full exploded view to show the multiple things that we have done as a system of layers, because in olden buildings they could do even a 3 feet thick wall to protect them from the heat. But in today's context, we cannot tell a client you build a 3 feet wall or a 4 feet wall. So instead of that, this is an adaptation of a thick wall, but broken in terms of layers, where the spaces between the layers still become spaces that people can come in and experience a space rather than just having it as a waste of space or a thick wall. So it's the same thing that is shown in where you have the fins, you have the water body, you have the terraces, and you have the skin wall. So another thing that we also did is took that program and said, okay, we have protected the roof, we protected the walls, and we have water body. How do we protect the heat entering from the ground? So what we did is we put in all the requirements that are not regularly used, such as cafeteria, library, training hall. We accommodated all this in the ground floor, so that again the office area, which is used through the day, is not getting the direct heat gain. So in that way we were able to protect it from the roof, the sides, and the ground. So, like I mentioned earlier, we incorporated the concept of earth air tunnel here. Here it was much more easier for us to incorporate it because of the space that we had around the building. And so this evolved from when we started to when we restarted the project just 2-3 years back. Initially, Initially, the earth air tunnel was supposed to feed not just the ground floor naturally cooled areas, which was the cafeteria and the library and all that, but was also supposed to provide uh, fresh air for all the AHUs on the upper floors, first, second, third, and fourth floor. But then it evolved, and they did not want to do earth air tunnel to such an extent. So now the EAT is restricted to the entire ground floor, and the upper floors, we have introduced a heat recovery wheel with the VAM chiller. So in this particular case, again, when we went to the site the first time, the first thing we observed was a lot of steam that was being generated as a byproduct. So then we said, why not use the steam so that we can avoid using a air cooled chiller or a water cooled chiller? Let's use the steam. So that's when we decided to have a vapor absorption VAM chiller, and with the heat recovery wheels for the upper floors, and the lower floors were all going to be cooled by the earth air tunnel. We're still trying to convince them to see if we can extend the earth air tunnel a little more, because we do have the space, and have that itself as fresh air for the other floors, but that's a challenge at this point of time. So the base case versus a proposed case, our target was at least 45% was our target, which I still feel we should get, because EAT calculations were not included, as that is not like a 100% guarantee. And when we submit it for any certification, they want like a foolproof system. So as a foolproof system, it's only 40%, that's 39.47. But we personally feel with all the design elements that there should be at least another 5 to 10%, because of all the shading devices that we have, because of the evaporative cooling, the EAT. We personally feel it should be there, and because we've gone to the site quite often after the skin wall and the fins have been constructed, and it definitely is much, much cooler than the surrounding buildings because of these elements that have been introduced. So here you can see the water body around the building and the fins over here. And these are the spaces that are there between the layers. So the skin wall, the water body, the fins. So these areas become as good social spaces for people to congregate and communicate with each other. Because at this point of time, what happens is either they're in their office or they're in the car going back to the house. They have absolutely no space that they can just sit outside even for a little time. So we we felt that lack of those social spaces was a key, and we wanted to integrate that into the design. And that's the reason why you see a lot of spaces that have been planned for them to experience the outdoors, because otherwise it's only indoor that they experience at this point of time. We really wanted them to sit outside and have the experience of nature.
Yeah, thank you so much, Meghna. That was a very uh, good description of how your thought process went into this building. And I can see that there is this common thread, that there is this exploration of optimum orientation, shading, glazing. You spoke about light shelves, courtyards, all of which is integral to a sustainable, energy efficient building design, whether it was the first building or the second project that we spoke about. So, from your experience, how much does the design brief influence this process?
So the design brief, it's usually very simple, because the client would not be aware very much about how the design can evolve, but he has a very clear picture of what it should stand for, what the building should stand for, that it should have an identity, it should set an example, or the goals that they have of what the building should speak is what the client is very clear about. And especially with regards to Raichur, Mr. Jamdar, who was the IS officer at that time, was extremely well read and extremely well versed with architecture. So it actually helped us in evolving the design language and the vocabulary for the project, because our ideas were always looked at positively, rather than saying, no, this is not what we want for a government building. It was always about, okay, let's see what more can we do. Let's see how much better can this be. So it was always a push from the client, which really helps us to explore more and be more innovative in how do we approach sustainability, and how do we look at design and sustainability together, rather than saying, okay, let's put our attention more towards design and less towards sustainability. It was never like this or that. It was always, how do we do it together? How do we look at both without compromising one or the other?
Right. And would you say, like, again, from your experience and in retrospect, that if a client is on board with, largely on board with sustainability goals, then it's easy to convince about the design, technology, or the, different strategy you want to implement in the building? For example, this earth air tunnel, how easy was it to convince the client that we have to, do this for your building? Did they accept it right away because they already had this vision, or did that take a lot of convincing?
So Earth Air Tunnel does take a little bit of convincing, but when the client already has a goal in mind, like how you said that they already know that it has to be sustainable and it has to be beyond just a certification. And if we explain it to them as to like, okay, if we do this, this is the consequence, this is what you will save, this is how you will benefit, and this is what it will stand for, and this is how your building will stand apart from the other buildings. So when you give them the right reasons and the right logic behind it, whether it is Puma or whether it was with KPCL, I think when we put all these things together and presented as to why we need to go with this, they were on board. They just needed to be explained. They needed that confirmation as to like this is the best way forward.
Right. Also, there are many architects uh, that I have interacted with
Hmm.
who are really interested in integrating low energy cooling strategies.
Hmm.
Uh, they are, they want to do this, they like to do this, but they do find that there is some or the other roadblock.
Hmm.
So, from your experience, other than these buildings, you have, of course, done so many other projects, which is already part of your portfolio. From your
Hmm.
experience, could you share some key pointers to them? What would you like to say to the other
So,
designers who are also aspiring to do the same thing?
so I don't see, there are always roadblocks, whether it's a sustainable project or a non-sustainable project or whatever project you take up. I don't think any project comes in as a platter, that saying, okay, everything that you say is accepted or everything that you say will work for that project. So there's always roadblocks, but we look at it as like every challenge helps us to innovate, helps us to come up with new solutions. And when you show them that you're not compromising on the experience of the spaces because you're making it more energy efficient, because there are some clients who already know they want it to be energy efficient, but there are many other clients who are not very particular. If it comes in as energy efficiency without compromising on any of the requirements, well and good, otherwise they'll say, no, that's not the most important factor for us. And so how we approach it is we don't really, those kind of clients, we don't really talk to them about saying, okay, you're going to save this much energy, you're going to save this much. We don't really talk to them about numbers or values or U value, nothing. We don't talk to them about that. We just talk to them about, the experience of the space, the lighting, the ventilation, the materiality, the textures, and just the tactile approach to architecture, because in reality the tactile approach to architecture is sustainable because you're bringing in all the natural elements into the building, and that's what we focus on, and you can't go wrong with that approach.
Well said, Meghna. And now I really have this one question. Obviously, we saw two projects across a different scale and function. One is a 5,000 square feet retail space, the other is a 90,000 square feet office building. So they both are completely different in context, in function, and in scale. Obviously, one is a you know government project, and the other is a international brand. So, given all of this, is scale a challenge when it comes to achieving sustainability goals? Are the effort uh, any different just because the scale is different?
Uh, the effort would be the same for any project because you approach each project as a new blank slate and you see how can you add value to this project? What can you do that makes it, be have a character of its own in some sense. But it is definitely more challenging when we talk about zero energy building in a small building such as PUMA because of a lot of constraints, the space constraint and the cost constraint also. In a larger project, when you introduce certain elements, the cost just spreads into a larger square footage. So it's not really experienced as a issue or a problem. Whereas in a small project like Puma, unless the client is really, really has that goal that it has to be a zero energy building, they would look at it like, why do I need to spend that 10% extra? Why do I need to spend that 15% extra? Even though you will get that back. With Puma, it was not a problem because they had the goal set. So that 10 to 15% was really not a problem for them because they knew they wanted a sustainable zero energy building. In Raichur, because it was a larger project, the cost kind of got diluted, so it was not a problem. Currently, we are trying to design a 15 lakh square feet factory building as a green factory. So that's a new challenge because in factory, we always are trying to deal with the people who supply the machines as to like, we're designing for machines, their main goal is like, let's design for the machines, not the people. So that's a different challenge that we face. So every project that we introduce the quality of spaces as key takes some time for the client to understand the value and why it should be integrated into the design.
Right. So, as I can understand, or rather, if I can summarize what you've tried to explain to us, is that as long as your approach is towards sustainability, then whether the building is a factory, like you just gave an example of, or an office or a store, the effort is probably the same. The scale doesn't matter, but every project has its own challenge, and it can only add to the uh, bring an interesting element to the project, and sustainability is a goal any which ways in a project. And I think when we have this approach, that's what I kind of want to get the point across to the audience is that as long as the approach is in place, then
Mhm.
it is definitely possible to create a high performing building to eventually reach the net zero energy goal. So once you are able to reduce the energy demand, and if you have space, then you potentially could generate that energy, produce that energy on site, which could eventually, you know, get a nearly zero or a net zero energy building.
Mhm.
So it's very much possible to do that.
Absolutely, Deepa, absolutely. It's really like you said, each client is different, and how you convey your message to each person to still achieve the same goal is the challenge. That's it, you know. As an architect, you're just doing what is responsible, whether in terms of energy efficiency or whether in terms of quality of spaces. Both are equally important. So, as an architect, we just have to approach both hand in hand.
Right, right. So, uh, this is another photograph of the building which is coming up. When is it targeting completion, Meghna?
So, in reality, as you can see, the structure is complete. So it's mainly and the
Right.
walls also are complete to a large extent. The walls also have been completed in the other areas, and plastering is going on at present. So if they really put their mind and effort to it, I think in 6 months they can complete the building. But being a government building, we always keep our fingers crossed and hope for the best.
Right. Yeah. Right. Great. So with that, it's time to take some questions from the audience. We already have a bunch of questions here. So I'll start, reading it out so you can answer them. This question is from Nikhil. If the PVC pipes are used for the earth air tunnel, can't perforation be done so as to increase the heat transfer properties, thus reducing the length?
No, you cannot perforate it because then you're getting the impurity from the outside to the inside. So it has to be sealed through and through from the time when it enters the intake up to the fan chamber. It has to be sealed. You can only have exchange, heat exchange, but you cannot have perforations of one material seeping and mixing in through the other.
Right. The next question is from Isha. What parameters were considered for the design of courtyards and how was it calculated for the KPCL project?
So when we designed the KPCL project, we went back and forth with the simulation team, which was Conserve Consultants based out of Chennai. So there was a lot of analysis done in terms of from the fenestration sizes to the locations of the courtyard to running the lighting simulations to ensure that every workspace within that office is getting natural light, and wherever they're sitting, they're able to look outside into the greenery. And see, we can space the two courtyards optimally, saying, okay, we're going to divide the building such that, it has this multiple areas. But that actual correction, like plus minus, was done through lighting simulation.
Okay. The next question is from Pooja. Since it's a earth air tunnel, is it likely to get condensation inside the tubes and which could lead to mold growth and result in a compromise of indoor air quality? How can we avoid this?
Yeah. So there will be condensation that we have to take it into account, such as any other system for air conditioning. There will be condensation, but what we do over here is it is always sloped. The pipes are always sloped towards the chamber where the water is, wherever the condensation happens, the water flows and it's collected in one location where it has to be pumped out. And in terms of filtration, so right in PUMA, the filtration was done after the air passed through the pipes and it was done in the basement. Whereas in Raichur, because of the air quality that is there outside, we have a double filtration system. We have a filtration right at the entry. So it's almost like a room. And we have these two layers of filter. So there's one filter where the air enters in first, and then the regular filter, because we don't want it to get damaged soon, because air quality is so bad in Raichur. So in terms of the filtration and the air quality, we can take care of it through planning it well in advance. In terms of condensation, you have to plan with adequate flow, because if you fail to do that, then you will have issues. So that has to be a prerequisite, and we are very clear about that, and we give them instructions and we show them what the slope should be, how the pipe should be supported with like little brick, like little brick support, so that the pipe sits over there at regular intervals, so the pipe doesn't bend or sag at any point of time in the future. So a lot of research had to be done for EAT, because there's not, it was quite challenging for us because it was the first time that we did it, and we could not find a consultant either who had done it prior to this. So it was the first time for us as well as the first time for the MEP consultant when we did for PUMA. For Raichur, we're more prepared because we've already experienced doing it for PUMA, and we had to do multiple research and search, and put together a complete kind of set of instructions and guidelines, and run with your instinct and take it forward.
Okay, the next question is from Sakshi. Is, I think she means was any action taken for LCA? I guess she means, was any study done for LCA of materials, life cycle
So life
assessment?
cycle, yeah. So with regards to life cycle analysis of materials, what we did do was a simpler approach to it. We didn't really calculate the exact life cycle cost or implication. What we did do was a simpler method where we, sourced the materials that are easily available, whether it's Bangalore or whether it was for Raichur. So for Raichur, it was very simple. Fly ash is a byproduct of any power plant. So we said all our blocks will be fly ash, so straightforward. And the materials that are available for flooring in those areas are like shabad and tandoor, those kind of materials. So we went with those materials. We didn't want to experiment and, import materials or anything. So it's more of just using locally available materials. So that's what we stuck to. We didn't really go into an in-depth analysis of life cycle costing.
Right, so we are almost up in time, and I think we don't have time to take more questions now. I'd like to thank you, Meghna. This brings us to the end of the webinar. I thank you for your time and your willingness to share all the detailed insights that went into the two projects. One is operational and one is under construction. We're really looking forward to the KPCL once it's up and running and occupied, and to see the beautiful spaces that you have created in reality. So thank you very much for your time. And with that, we come to the end of the session. And just before we end, I'd like to tell my audience that in the next week, we have a presentation by architect Sanjay Prakash about the approach and strategies for a large-scale net zero development, that is IIT Jodhpur. So we're going to talk about master plan level strategies. So do tune in next week for the same thing at 4 p.m. And with that, thank you very much for attending this webinar, and see you next week.
Thank you, Deepa. Thank you so much for having us. It was
Thank
our
you.
pleasure. Thank you.